This lesson is on the product rule. So we did learn some other rules previously. The product rule is going to help us do some more difficult questions. It's going to help us save some time when simplifying so that we can basically do questions more efficiently. So in order to use the product rule, you need to have two differentiable functions that are being multiplied together. So this says if p of x is equal to f of x times g of x, where f of x and g of x are differentiable functions, then p prime of x, the derivative of p of x, is equal to f prime of x times g of x plus f of x times g prime of x. So basically is equal to the derivative of the first function times the original second plus the original first times the derivative of the second. We are going to be going through a couple of examples. So example 1, find the derivative of each using the product rule. So this first example that we're going to be doing today, f of x is equal to 2x cubed plus 5 times 3x squared minus x. Now, I know that we have done questions like this in the past, and we could very well just expand this out and use the power rules that we talked about. But if something were, to be to a power of 4 or anything like that, things kind of do look a little bit messy. And so we are going to use this derive this using the product rule. So the product rule says that f prime of x is equal to, and I guess before I go on, I'm going to stop for a second. So this is our first function, and this is our second function. So f prime of x is equal to the derivative of the first function, so the derivative of 2x cubed plus 5. So we're going to take the 3, multiply by the 2, and we're going to get 6x squared because we're lowering this power by 1. And our plus 5 is a constant, so it goes away, multiplied by the original second, plus our original first, so the 2x cubed plus 5, times the derivative of the second. So we're going to take the 2, multiply by the 3, and we're going to get 6x to the power of 1 because we're lowering it, minus the derivative of x. Remember, there's like an imaginary 1 here, so the derivative of x is just 1. Now, at this point, we could simplify this a little bit further. Since the question just says find the derivative and it doesn't say simplify, I am okay with you stopping at this line. This is what I really just care about. My next example is f of x is equal to 1 over x times x squared plus 1. So again, I have my first function being 1 over x and my second function being x squared plus 1. Now, before I start this one, I am going to rewrite this just like we've talked about so that it is x to the negative 1. That makes it a little bit easier for me to think about when I'm deriving using my power rules. So f prime of x, or my derivative, is equal to the derivative of this first function. So bring my exponent down and lower my exponent by 1. So that's a negative x to the negative 2 times my original second function plus the derivative of my second function multiplied by my first original function. So my first original function is x to the negative 1, and the derivative of that second function there is 2x. Now, at this point in time, I am going to rewrite this. I don't like these negative exponents, so I am going to be getting a negative 1 over x squared times x squared plus 1 plus a 1 over x times 2x, and I could go ahead and simplify that even further, but the question doesn't ask me to, so I'm just going to stop here. So this second example says, show that the derivative of f of x is equal to root x times 2 minus 3x using the product rule and the power rule. Now, in order for us to show that these two derivatives are equal, we will need to be simplifying both of these answers to make sure that we did it correct. And in order for us to use the product rule and the power rule, I am going to be rewriting this function so that it is a little nicer for us. So f of x is equal to, and instead of a root x, we are going to be rewriting it as an x to the 1/2 times 2 minus 3x. Now that I have that, I'm going to go ahead and I'm just going to be using my product rule first, just because that's what this note is on and that's what we just finished doing. So when I'm using my product rule, I'm going to be saying f prime of x is equal to the derivative of that first function. So 1/2 x to the negative 1/2. So again, what I did was bring that exponent down and subtracted 1 for my new exponent, times my original second function, plus my original first function multiplied by the derivative of that second function. So since the 2 is just a coefficient, it goes away, and all I'm left with is this negative 3. Now, just as a preference, you can choose to do this either way. So you could have done the derivative of the second function times the original first function. It doesn't matter which way you're doing it since we're multiplying. I'm going to go ahead and I'm going to simplify this a little bit further and exchange those negative exponents. So what I'm going to be getting is a 1 over 2 root x times 2 minus 3x plus a root x times negative 3. I'm going to go ahead and simplify this a little bit more. So we can imagine this is over 1. When I multiply two fractions, I'm going to do top times top, bottom times bottom. And I'm going to be getting 2 minus 3x over 2 root x plus, actually, I'm going to be getting a minus 3 root x. Now, I'm going to go ahead and I'm going to get a common denominator so I can simplify this a little bit more. So we know that this is over 1, and if I want a common denominator, I'm going to be multiplying this by a 2 root x and this by a 2 root x. So I'm going to be getting 2 minus 3x over 2 root x minus 3 times 2 is 6. Root x times root x is x over 2 root x. And I can go ahead and simplify this a little bit more, and I can get 2 minus 9x, all divided by 2 root x. Now, I could go ahead and I could rationalize that. I am just going to leave it for now, just because all I'm doing is comparing my answers. We are going to redo this derivative using the power rule. So what I did was I just rewrote my f of x from the previous slide, just in case you forgot or you weren't writing down. You can follow along. So before we can go ahead with this derivative, we are going to need to expand this. So I'm going to be multiplying this x to the 1/2 through to every term in this next bracket. So 2x to the 1/2 minus 3x to the 3/2. Now, just in case you are unclear on how I got that, there is an imaginary 1 here, and when I'm multiplying something with the same base, I add the exponents. Now that I have this simplified, I'm going to go ahead and write my derivative. So f prime of x is equal to, this exponent needs to come down and be multiplied, so 2 times 1/2 is 1. So I'm going to get x to the negative 1/2. And then the same thing, this is being multiplied through, so a minus 9 over 2, x to the 3/2 minus 1 is a 1/2. Now I'm going to go ahead and I'm going to rewrite this. So I'm going to get a 1 over root x minus 9 root x over 2. Now if I'm going to simplify this, I am going to have to get a common denominator. So I'm going to be multiplying the top and the bottom of this one by 2 and the top and the bottom of this one by root x. 2 over 2 root x minus 9x over 2 root x. And then simplifying a little bit further, 2 minus 9x over 2 root x. And as you can see, or if you flip back to the previous slide, or if you're just going to trust me, they are definitely both the exact same answer. So this example wasn't bad using the product rule or the power rule. Sometimes on assignments or tests, you will be told to use a specific rule, and other times you're going to be allowed to choose whatever you think is easier. Like I mentioned, this one, I think they're probably both equivalent in terms of difficulty, but other questions it is going to be a very clear easy method versus hard method, so it is definitely in your best interest to know both methods equally well. Example 3 says, find the slope of the tangent line to the curve f of x is equal to 3x squared plus 2 times 2x cubed minus 1 at the point 1, 5 using the product rule. So we can clearly see we have one function here and a second function here. So I'm going to go ahead right away and I'm just going to jump into the derivative. So when we're doing this, we are going to have the derivative of that first function, so a 6x multiplied by the original second function plus our original first function, ugly 2 there, plus 2, multiplied by the derivative of that second function, so a 6x squared. Now again, I'm going to go ahead and simplify this just because I do need to use that simplified version to do some more work in this question. So I'm going to multiply this 6x through, and I'm going to be getting 12x to the 4 minus 6x plus this 6x squared is going to be multiplied through 18x to the 4 plus 12x squared. I'm going to go ahead and combine these like terms, and I am going to get a 30x to the 4 plus 12x squared minus 6x. So now what we have, since we've determined the derivative of this function, is we know that this is equal to the slope, and since it gives us a specific point that they want us to find the slope of the tangent line, we are going to go ahead and plug in that x value of 1. And so when I do that, I am going to be getting 30 times 1 to the 4 plus 12 times 1 squared minus 6 times 1. So 30 plus 12 minus 6 gives me 36. That's it for this question. That's it for this note. In the next lesson, you are going to be seeing a proof of the product rule. It is good just to know how to think about proofs, how to write proofs, and definitely at least to understand what's going on as I go through and prove that for you.